Chapter 1.1.2.3 Labels and Selectors. Labels are key value pairs used to identify attributes of objects like pods. They are not directly related to the core system, but are helpful for organizing and selecting subsets of objects. Each object can have unique key values, and labels can be added or modified at any time. They allow for efficient queries and are useful in UIs and CLIs. Non-identifying information should be recorded using annotations. Motivation. Labels allow users to organize system objects based on their own structures without the need to store these mappings. Complex entities like service deployments and batch processing pipelines often have multiple dimensions, such as different partitions, releases, tiers, and microservices. Cross-cutting operations are necessary for managing these entities, which may not fit neatly into strict hierarchies. Examples of labels include release, environment, tier, partition, and track, but users can create their own conventions as long as each label key is unique per object. Syntax and character set. Labels in Kubernetes are key value pairs with specific requirements for valid keys and values. The key must have two segments with an optional prefix and a name separated by a slash. The name segment must be 63 characters or less and begin and end with an alphanumeric character, allowing dashes, underscores, and dots in between. The prefix, if included, must be a DNS subdomain not exceeding 253 characters. Certain prefixes like kubernetes.io/ and k8s.io are reserved for core components. Automated system components adding labels to objects need to specify a prefix. Valid label values must also be 63 characters or less, with similar alphanumeric character requirements. An example of a pod manifest with two labels, environment, production, and app, Nginx, demonstrates the use of labels in Kubernetes. Label selectors. Labels in Kubernetes do not provide uniqueness, as many objects can have the same labels. A label selector is used to identify a set of objects with two types supported, equality-based and set-based. Multiple requirements can make up a label selector, separated by commas and acting as an AND operator. API types using selectors should document their validity and meaning, as conflicting instructions can cause issues. There is no logical OR operator for filter statements with both equality-based and set-based conditions. Equality-based requirements filter objects by label keys and values, with operators such as equals for equality and inequality. For example, one can filter resources by key and value, or select resources with specific keys and exclude certain values. Set-based requirements filter keys according to a set of values, with operators like in, noten, and exists. This allows for filtering resources based on multiple values for a single key, or just the presence of a key, with the comma separator acting as an AND operator. The set-based label selector is a more general form of equality, where filtering resources by a single value is equivalent to using the in operator. Set-based requirements can be combined with equality-based requirements, allowing for complex filtering conditions to be specified. Overall, labels and selectors in Kubernetes play a crucial role in identifying and managing sets of objects within the system. The text discusses the use of label selectors in Kubernetes for filtering lists and watches of objects, such as services, replication controllers, pods, jobs, deployments, replica sets, and daemon sets. The label selectors can be equality-based or set-based, with set-based selectors being more expressive as they can implement the OR operator on values and restrict negative matching. Resources like services and replication controllers define the sets of pods they target or manage with label selectors in JSON or YAML files using maps, supporting only equality-based selectors. Newer resources like jobs, deployments, replica sets, and daemon sets support set-based requirements as well, with match labels and match expressions being used to specify requirements. The values in the selectors can be constrained to constrain the set of nodes onto which a pod can schedule. The text also mentions using query parameters in a URL to specify label selectors for list or watch operations via a REST client targeting the API server with kubectl, providing examples of both equality-based and set-based requirements in the URL query string. Using labels effectively. Using a single label for resources may not always be the best practice. In scenarios where resource sets need to be distinguished, multiple labels should be applied. For example, different applications may require different values for the app label, while a multi-tier application like the guestbook example would need to differentiate each tier with labels like tier and role. Labels allow for organizing resources along specified dimensions. Updating labels. The text explains how to relabel existing pods and resources using the kubectl label command. This is useful when you want to assign new labels to pods before creating new resources. An example provided is labeling all Nginx pods as front-end tier by running a specific command. You can then view the labeled pods by running another command that outputs the pods with their additional tier label. For more information on using kubectl label, refer to the documentation.